Okay, I'm going to repeat myself a little bit for the online students because I forgot to hit record. So again, we're doing unit 11 here. This is our second week of 3 weeks we're spending on arrays and lists here. And so we're working on the learning materials. And we're doing this POGL activity here. I'll post the teams here in just a sec. And here's what our initial teams are. These might adjust in just a sec. So in-class students will work on this in class, although you can stay in your separate spots. Online students, you can work on this. What I suggest is that maybe the facilitator create this document and share it with the other people in the team, and then each of you do your own part separately there. You can do it however you want. This is just a learning activity here. So you don't have to turn it in or whatever. It's just something important topics, things that you should know for a career in computing, things you should know for the final exam, that sort of stuff here. So open this up, share it. Whoever opens it up first should share it with the other people in the group and start working on at least your sections and any student sections of this. And again, you should be open up this document here. Where's my zip code? Here's the new zip code project. When you run it right now, it'll do a sequential search through a set of zip codes, right? So it's the enter zip code. Here's Scholastica's one. It'll search through. After searching for 313 zip codes, it'll find Duluth here. So your job is to learn more about this code, how it works there. So I'm gonna let you play with that and see what you can find out. Okay, let's take a break and hear from some of the teams here on what you're doing. So you've hopefully downloaded this software and started looking at it here. One thing that's useful when you're learning a program is it is challenging to look at software that you didn't write, but it's a good thing to practice because a lot of your coding, if you do a lot of coding, a lot of what you do will be trying to understand other people's software. So the first thing here is this software has two arrays of strings, one called zip codes and one called city names. What can you tell me about them? So would we have, who's the spokesperson in the first team there? So the spokesperson is Emmanuel. So what do you, isn't that, it says that right there. Yeah, right. So, okay. So what, now, in a perfect world, there'd be little comments here that would describe what these are, but there aren't. So what is your guess at what's stored in the zip codes and the city names? So
I'll just say the array is like five character for the array. So this is 5 character.
5 characters for the zip code. Yeah. So right. The one thing we can do, although it's not common there is a method down here called read CSV. Have you ever heard of, anyone ever heard of a CSV? What do those initials stand for when you talk about a file? When you talk about a CSV file. So that means comma separated values there. It's a way of organizing files. So here, here's the actual file there. Let's see if I can zoom in on. So we have the zip code and then the name of the city and then another zip code. And so each one is on their own line and they're separated by commas. So that's what the CSV. So we are actually reading this comma separated values in for the zip code and the city name. So that's what this, you don't have to understand all this code, but that's what that code is doing. And about now you could probably start understanding what that code does. But this is all the zip codes here in Minnesota for this. So, okay. When we run it, okay, when we run this and enter a zip code, and it finds it, it'll just tell me it found it after searching for a certain amount of time. What happens when you run it for a zip code that's not in the list? It gives us this error, array index out of bounds exception, index 819 reached, and it was out of bounds. So what did you figure out about that? What is causing that array index out of bounds error?
I didn't really figure out why it was doing that, but I figured out how to solve it.
Okay, how do you solve it?
I use for loops to
Okay.
have it safely return that -1 isn't a match.
Okay. So that's, yes. So in sequential search, we are just doing a while loop, looping through, we keep adding one to the index. So basically what it does, right, is we have this array and it just starts and we're searching for, let's say we're searching for 99. So it looks at the first one, nope, looks at the second one, nope, looks at each one of these one by one, keeping adding one to the index. So like this would be the index here. And eventually, when we get down to the bottom to 8,018, it looks at that one, 8,019, 8,020, and then it tries to look beyond that and it fails. And this is 8,020. It actually started counting at 0. So in its mind, this is actually 8,019. And it tries to look one more and it fails because the array isn't that big there. So you're saying we could convert this to a for loop rather than a while loop there. And that would be, that's a good solution to it, okay? Other solutions? Caleb, I think I heard you saying something about try catch. We haven't talked about try catch, but try catch is a way of try and code out, and if there's an error, catching it and returning some value there. So where were you putting in a try catch?
Around the while loop.
Yeah, around the while you're doing this in a try catch. So, yeah. And that's an option. Anyone else come up with a different solution, Ryder? Okay, and if it is, right, so that would be another, so again, you could do a for loop to the size of the index, so then you know you're not going bigger. You could do a try catch, or you could do this if, so when you increase the index, if the index is greater than the size of the array, zip codes, length. So if you've run out of places, then we're just going to return -1. So any of those solutions, I'm just doing this one because I think it's the easiest to do. So if we look up some zip code that can't find, I'm still. Why did I still get an error here? Try that again.
We could do zip code dot length -1 or index -1.
Oh, maybe I need index is greater than or equal to. That's probably what I need. Yeah, because if it's equal to, then we're running that problem. Yeah. It just says zip code not found then. Okay. Why does it print out, like, if we do find a zip code here? It prints out the index. What does this index mean? What does that do? David, I think you're a spokesperson. Tell me something about that. What's the index when it says found a match at index 3313? Do you guys figure out? Do you know what that does?
We have
Okay, that's fine. All right. Yeah, it's good to get get a good understanding of that. So this index, when we say was found at index 313, what is that 313? And is it always the same value? Well, better yet, when you did your sequential search, record the indexes. What are some examples did you find? How long did it, how many zip codes does it find here? So how many zip codes do you know in Minnesota? So do you know the zip code of Warroad? It's 56763 there. Or Crookston is 56716. So let me try those. 56716. It searches through 709 of these. So again, it's searching through all of these zip codes until it gets down, and it will have searched 790 of them before it finds a match, because it is just going one by one through them. So the sequential search is very slow there. How many zip codes are there in Minnesota? Anyone figure that out? 820? Sounds good. How many zip codes are there in the United States? Anyone find that out?
41,700. That was according to the App Store.
About 41,000? And that's not, there's about 1,000 in Minnesota, and there's about 50 states. Minnesota's maybe about an average size state there. So I would make, so if I were to guess, I would guess around 50, 50,000 and 40-some thousand. That sounds about right. There's about, 40 to 50,000, I would say, 40,000 zip codes in the United States. So when you're searching through that many zip codes, it can get a little slower here. Now, nowadays we use zip +4. So we use the standard 5-digit zip codes +4 more digits to be very specific. Did anyone find out how many zip +4 zip codes there are in the United States? There are a lot. So, no, not there. How many zip +4 codes are there in the USA? So there's about 44 million zip codes here in the US. So about 40 million, I would say, depending on how you count for that. So there are a lot. So now if you were going to go through sequentially and find all of those, that would take a long time there. So let's try this other one. So have you been able to do anything with the binary search yet? So try to do that. Go up here, change this right at the top where the main is. We have this sequential search. I want you to comment out the sequential search and uncomment the binary search. So now we'll find the binary search. So enter a zip code and it'll find it. Now, I would like you to put in some print statements right now, look at the binary search. What we'd like to do is count how many times it's going to search. So what the binary search is going to do, if you remember the binary search, right? It will say, like, let's say we're trying to find 55811. It's going to jump to the middle and look, and 55811 is less than that, and it'll jump. So it's above this. So I mean, in this section up here, smaller one. So it'll jump in the middle of that section and look. 558 will be below this, so it'll jump between this and my other one. So it'll jump down here, and it'll keep trying to divide this in half until it finds the right value. That's what the binary search is doing. To look through this code, see if you can understand this. What we want to do is count how many times it does something. So put a count inside your while loop and then print out that count there. So that when we find a value, it'll say found a match after checking like 9 zip codes or something like that. So try out some different values and see what it is and see how long. Because again, with sequential search, it could take up to 800 searches or checks before it found you have to look at 800 indexes. Hopefully binary search will be a little faster than that for this. So, okay, I'll let you work on that a little bit more. So the binary search will divide our list in half here. How many times does it take to find values in here? So if I run this, how many times will it try something? You set this up well, so like it can find Duluth in 8 matches, 55811. It'll find that in 8 matches. Here, if I try a different one here. Let's try a different, like 55812. You'll find it in 10 matches. So some of it will find slower, but some of them will find like it'll take up to 10 matches to find these values, right? So how, why is that, and how, so if you remember, there are about 800 values, zip codes, 820 zip codes in Minnesota. So let's look at that. If you remember, so how many would it take if there were like, if we had all the zip codes in the United States, so like 30 or 40,000, how many indexes would we have to search? How many zip codes do we have to look up to do a binary search through 30,000 records for that? It's like 20 questions. I mean, so every time we do another lookup, we can divide the zip codes in half, right? So you can actually just do this with a calculator. You can say, okay, what is 2 times 2? That's 1, 2, 3, 4, 5. It's doubling each time. 5, 6, 7, 8, 9. So 9 times I'm up to the size of Minnesota. So that's 9, 10, 11, 12, 13, 14, 15. I should be able to find any one in the United States. But what about the zip plus 4 here? So what is it? I think 14, 15, 16, 17, 18, 19. Again, in 20, I'm at 4 million, 21, 22, 23, 24. I can get to 60 million in about 22 guesses. So I can search through all this stuff very quickly for this. So again, the average number of guesses, the max that would be the max you could have to guess for that. And if you compare that to up here, if you were searching linear through this, it would take a lot longer for this. So, okay. We're running out of time today, so I'm gonna wrap this up again. So you can work through this. Again, this is not for points. You don't have to turn this in. I will never see this. It's just for your learning activity. Okay, so feel free to finish this up if you want, but don't if you don't want. Let's look at the next thing, the learning activity. We'll spend time on that. Well, actually, before I just want to point out, if you had trouble with the pesky tourist, here's a little analysis of that stuff. So you had to do a couple things. You had to move values in and out of arrays, find the median, the middle of three values, and then return the correct array from a method. So there's some complicated stuff you had to do. Now, finding the median of three values is hard. Well, it's easy if they're in order. If you have three numbers and you want the middle one, and they're in order, first one is in the 0th position, second one is in the the first position, third one is in the second position. You can always grab that middle one, and it's the middle one if it's sorted. But our array wasn't sorted. So if you use AI usually tries to sort these numbers and then pick the middle one. But you can, even if they're not sorted, there are a number of combinations you can look at here. You can look not the first number could be in the middle, and and that's the one you'll want to return the first number if number 2 is less than number 1 and number 1 is less than number 3, or number 3 is less than number 1 and number 1 is less than number 2. So these are the two conditions where number 1 would be the first array value would be the 1. Same here for the second one. You can structure these if-thens in different ways for this. So just a note, if it bothered some of you that we are working with one-dimensional arrays, to make things simpler, move this. But and so if you want to see this as a two-dimensional array or arrays, here's a version that does a two-dimensional array output of this. So yeah, so feel free if you're still confused. Again, this doesn't help you. It doesn't give you the solution, but might give you some hints as how to do this. And feel free to talk to me if you're still having trouble struggling with this. The pesky tourist can be a complicated problem to try to solve at this level. Okay, we're going to look at this Conway's Life game. I'm going to introduce it today, and then we're going to spend most of the day on Friday working on this learning activity here. We're going to download this. I'm not going to do it right now. I'm just going to talk. I'm just going to talk about Conway's Life here. Have you heard of Conway's Game of Life before, or it's really a simulation there? You can just Google Conway's Life and bring up a number of these websites that'll let you simulate it. Here's one. Here's playgameoflife.com here. And I can click on these patterns and hit start, and it will update the patterns here. So I can create a different pattern, and there are different rules that are applied for these patterns and what they do for life here. That's what we're going to look at a little bit. So let me see if here, I'm going to open up chapter 15 here, and it talks a little bit about Conway's Life. It shows this example. So here are the rules. A live cell with fewer than 2 neighbors dies of underpopulation. So this cell over here, the neighbors are the 8 cells around it. It doesn't have enough neighbors. It's going to disappear the next time. So a live cell with fewer than 2 neighbors, there with, is gonna, a live cell with 3 neighbors, or more than 3 neighbors dies of overpopulation. So like this cell here, it has 1, 2, 3, 4 neighbors. It will die off in the next update, here. And then, a dead cell with exactly 3 neighbors becomes live. So like, this cell here will become alive because it has exactly 3 neighbors. So we can just do an update. We'll see this one disappear. We'll see this one come alive. We'll see this one disappear. I can just do next, and I have an update here. And again, we can we update all the cells and then redraw this. And then we do this. And when we get this, every time we use these 3 rules, and when we run this, we get these interesting patterns that evolve or generate themselves over time for this. And you get amazingly complex patterns here for based on these 3 simple rules that we have here. So we're going to open this. We're going to do this in Java here. So again, the textbook walks through this a cell class, a color class, a 2-dimensional arrays there. This is probably more complicated than you need. And so we're going to do a kind of a simpler version of this here. So we will provide you either GitHub or a zip download that where you can do. And then we're going to have you describe some of the code, what this does. So what does this code does? And do some changes to the code there, and then generate, turn on some values, and then run the code. This is what this sort of idea here will be how we'll generate. Oh, this is still going here, this example. Okay, I'm going to reset. So, oops, so. I don't know if there's a clear button. Okay, so like in your example, we'll be turning on like 2, 1 would be maybe this one, and then 2, 2 would be this one, and then 2, 3 would be this one, and then 1, 7. Here 1, 2, 3, 4, 0, 1, 2, 3, 4, 5, 6, 7 is here and here and here, maybe. So again, this is how we turn on the pattern. Then we'll run it through a simulation and see how it goes. So this is what we'll work on in class on Friday. Okay. I'm good. See you on Friday.